Hello students, in this video we are going to discuss about the concept regression analysis. So this is also a very interesting idea. It's a continuous process of correlation analysis. So correlation we learned before. So correlation is nothing but we are finding the degree of relationship between the two variables if the relation exists. But the regression analysis is nothing but we are finding what is the relationship between the variables. That relationship itself we can find by using regression analysis. So that is the difference between correlation and regression. So correlation analysis means finding the degree of relationship between the two variables if the relation exists. Regression analysis means finding the relationship between the variables. It is a major difference of the two ideas, correlation and regression analysis. So in regression analysis, we are following the linear regression analysis. Linear means it represents a line that is obtained by the principle of least square. So naturally we have two variety of regression lines. The first one, regression equation of y on x. Regression equation of y on x. So it's nothing but y minus y bar equal to sigma yx into x minus x bar. That is the equation represents regression equation of y on x, where x bar is nothing but arithmetic mean of x, summation x by n, and y bar is summation y by n, and sigma yx. Sigma yx is nothing but standard deviation of the variable yx. We are going to compute what is yx. For that variable, we need to find the standard deviation. That is the meaning of this notation, sigma yx. Standard deviation of yx is calculated by in two formulas. First formula is r into sigma y by sigma x. If you know the standard deviation of y separately, x separately, and also r means correlation. So if you know the correlation coefficient, standard deviation of y and standard deviation of x means you can apply in this formula, we can get sigma yx. Or another formula is also available. Suppose sometimes data will be given. If you have data, then we have to use this formula n into summation xy minus summation x into summation y divided by n into summation x square minus summation x whole square. So this is the formula. So here n is nothing but number of observations. Here n is number of observations. Right. So using this one of the two formula, we can find sigma yx. According to the data, we can use that formula. Next, we go for the next regression equation. That is regression equation of x on y. Regression equation of x on y is nothing but x minus x bar equal to sigma xy into y minus y bar. So similar idea only here. So this is the equation of x on y. X on y, x minus x bar equal to sigma xy into y minus y bar. Where same ideas. X bar is the mean of x, y bar is mean of y. Summation y by n, and the standard deviation for xy, sigma xy is defined as r into sigma x by sigma y. Or you can use the another alternate formula, n into summation xy minus summation x summation y divided by n into summation y square minus summation y whole square. So this is the formula. That the same, n is the number of observations or data. Right. So these are the two major equations on regression analysis. This is the idea here. So for the given data, we have to find these two regression equations. And the main purpose of the regression equations is the thing that you can find one variable if you know the another variable. For example, if x is related to height of the first person and y is related to weight of the person means, if height is given, we can find what is the corresponding weight, or weight is given, we can find what is the corresponding height. With that, you can go vice versa. That is the main use of this regression analysis. In problems, easily we can understand those things. And some properties are there. Those are all some important properties here. I will tell that also, because in problems we may use that. Properties of regression coefficients. First property, dyx into dyx. Sorry, dyx into dxy equal to dyx means r into sigma y by sigma x. This is r into sigma x by sigma y. So now if you multiply this sigma x, sigma x, sigma y, sigma y will cancel, we can get this r into r square, that is dyx into dxy. So from this you can get r equal to plus or minus square root of dyx into dxy. So you can obtain the rank, or you can obtain the correlation. R means correlation. It's a correlation coefficient using the regression coefficients. R is the correlation coefficient. dyx and dxy are called regression coefficients. Here R is correlation coefficient. dyx and dxy are regression coefficients. So this is the relation between correlation coefficient and regression coefficient. This is one important property we are going to use, that is as a formula in some problems. And second thing, second one is the regression coefficients are always both are positive or both are negative. When you find the regression coefficient dx and dyx for the given data, both value will be positive or both value will be negative. Yeah, that is a character the regression coefficient is having. Suppose if we have mixed sign, plus and the minus means we cannot get the relation, we cannot get the regression equation. That is correct regression equation, that not represent a regression equation. If you have like that, that is not represent a regression equation. So if we have this property, then only that is called a regression equation. So this is another important property of regression coefficient. These are the two important properties. So based on this, We are going to discuss one problem here. So first problem, uptime the least square regression line, uptime the least square regression line. Regression line is the regression equation. We can call regression equations regression line of y on x, regression line of x on x. Equation line for the same only here of y on x. See in this here we are deal with linear concept. That's why they are mentioning lines here. Okay. Regression line of y on x for the following data. The data is x with y 1, 2, 3, 4, 5, 6, 7, 8, 9. Y values are 9, 8, 10, 12, 11, 13, 14, 16, 15. Also, uptime and estimate of y, which should correspond on an average to x equal to 6.5. That is the main interpolation. We have to interpolate one value of x equal to 6.2. What is the corresponding value of y that we have to find? Right now, we move for solution. So this is a question. So x and y values are given. Two variables are defined here. For the two variables, we have to define what is the relationship between the two variables. We have to express that as an equation. That equation is nothing but y on x equation. We have two kinds of equation, y on x and x on y. They are asking for y on x equation. That relation they are asking. So we need to find that one. So just frame the table now. First take the x value, y value. Then we need the multiplication of two values, x into y we need. The same problem we can find y and x equation also. Y and x is given, x and y also. X and y also we can find. So I will proceed for y and x here. Next problem I will do for this. So here x, y, xy, x square. See, whenever a problem is given, you do for both the keys. Just find x square, y square, x square. Okay, if you find one more value y square means we can get y and x also. Okay, I will do that also here. So for x square, y square, x square. This is a common format. Common format for whenever the question is asked in regression analysis. First find all those things. What is the x value given here? 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Y values 9, 8, 10, 12, 11, 13, 14, 16, 15. Now square these x values. X square 1 square is 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square is 64, 9 square is 81. Similarly, y square, 9 square is 81, 8 square is 64, 10 square 100, 12 square 144, 11 square 121, 13 square 169, 14 square 196, 16 square 16 square 256, 15 square 225. Then multiply x into y. X into y. So 1 into 9, 9. This you have to multiply. Then 2 into 8, 16. 3 into 10. Now multiply these values. 1 into 9, 9. 2 into 8, 16. 3 into 10, 30. 4 into 12, 48. 5 into 11, 55. 6 into 13, 60 plus 18, 78. 7 into 14, 56. 8 into 16, 134. 80 plus 48, 120, 128. Next 9 into 15, 190 plus 45, 135. Right, now sum all those values because we need everything. We need all the sum values. So sum all the values. First find the summation x. Sum all the 9 values. 10, 20, 30, 40, 45. Find summation y. Add all those things in it. Not 8. The sum of square value summation x square plus 85. So we go for summation y square and all the things taken here. So finally summation x into y. This summation x y. Wait, I think here this entry is wrong. This entry is 7 into 14. 7 into 14 is 70 plus 28, that is 98. So total will be 597 as a correct value. Right, this is the summation x5 value. Therefore, go for the solution now. To the equation of y and x. So the regression equation or line of y on x is y minus y bar equal to sigma yx into x minus x bar, where x bar equal to sigma x by n. You know what is sigma x? Summation x is 45 divided by n, number of data. The total 9 data are given. So 45 by 9 is 5. This x bar. Y bar equal to summation y by n. Summation y is 108 divided by 9. So here 1 time plus 1, 12 times. So y bar equal to 12. This is x bar and y bar. Then we need sigma yx. Sigma yx equal to, we have two formulas, r into sigma y by sigma x. That formula we cannot use here because we don't know r, sigma y, sigma x, those values. But we know the summation values. So use that summation formula. So n into summation xy minus summation x into summation y divided by n into summation x square minus summation x whole square. This formula we can use here. Now what is that n? N is 9 into summation xy. Summation xy we got 597. 597 minus summation x is 45, summation y is 108. This is 45 into 108 by 9 into summation x square. Summation x square is 285 minus summation x whole square is 45 whole square. Let's simplify this. 9 into 597. 9 into 597. 5,373 minus 45 into 108. That is 4,860 divided by 9 into 285. That is 2,565 minus 45 square. 2,035. Let's simplify this. We can get sigma x. Therefore, this value is 5375 minus 4860. The value is 515 divided by 2565 minus 2035. The value is 540. 540. Therefore, sigma yx equal to 515 by 540. 515 divided by 540. That is 0.9537. So this is a value for sigma yx. So see that sigma x is positive. That means definitely sigma xy will also be a positive by the property. Okay, to find sigma xy, that is also will be a positive value. That work I leave for you. You just find what is the equation of x on y. Okay, but see, for that purpose only I found here y square. Okay, summation y square we used there only for the equation of x on y. I found this. Just you find what is the regression equation of x on y by using the formula sigma xy. That is the only one thing you have to find. Sigma xy apply here. Numerator is same only. Denominator only will vary. Denominator is n into summation y square minus summation y whole square you should take. Numerator is same. 515 will come. Denominator only will vary. After that this value will vary. That's all. Okay, that is the extra work for you. So just you find that and you can get the equation of x on y also for the same data. Okay, I am doing for y on x here. But in examination this is no need. Okay, suppose if they ask y on x, means no need to find y square. Okay, because in y on x square only we need. So just find x square itself. I am doing for generally I am doing like this because if you write all the 5 columns, you can solve any kind of question we can solve. That's why I included y square. For this problem, y square is no need actually. But you do that. You do for x on y using this y square value. Okay, you try that one. Okay, then only the problem will be familiar to you. Right. Now substitute all those values in the equation. Therefore the equation of x on y, y on x is y minus y bar. I think y bar is 12. That is equal to sigma yx. Sigma yx 0.9537 into x minus x bar is 5 we got. Here x bar is 5, y bar is 12, and sigma yx is this one. From this y equal to, just multiply this inside, 0.9537 into x minus 0.9537 into 5. That is 4.7685. 4.7685. You have to multiply this. Okay, multiply this into 5. Then take this minus 12 to that side. Yeah. Then this minus 12 comes here plus 12. Therefore, y equal to 0.9537x plus 7.2315. 7.2315. So this is the regression equation of y on x. Got a given problem. So here one more question is there. When x equal to 6.2, when x equal to 6.2, what is the value of y? They are asking. Okay, easily we can find that one. So put x equal to 2 here. What is y equal to? 0.9537. X value is 6.2. I think that is not true. 6.2. So substitute 6.2 plus 7.2315. Accordingly get, just multiply this 0.9537 into 6.2. We'll get 5.5.99 plus 7.2315. Just add these two values. 13.1444. Goes like this. 13.1444. So this is your y value. Or simply we can tell this is 13.14. The y value is 13.14. For the x value is 6.2, y value is 13.14. So this problem is given. So I hope you understood this concept. So we will meet in next week. Thank you.